Hi, my name's Keith. In this video, I'll be giving a tech overview of the ARP Omni. It was manufactured between 1975 and 1981 and was ARP's best-selling synthesizer. There were two versions of the Omni, the Mark I and the Mark II. This is a Mark I, and I'll go through the differences as I proceed with the video. The Omni has a string section and a synthesizer section, and they're fully polyphonic with some limitations. This is a tech video, so I won't really be going through sound creation, but I will be noodling about on the keyboard while I go through the different sections, so you'll be able to hear what it sounds like. Let's start with the front panel. The Omni is split into two sections, with the controls for the strings on the right and the controls for the synthesizer on the left. With the strings, they have four sounds: bass, cello, viola, and violin, and they correspond to four banks of modified square waves. And there's also attack and release for the envelope for the strings. So if I select the violin and viola, you get the typical phasing string sound. There's a three-stage phaser inside, and the strings always go through that phaser. With the bass and the cello, they only are actuated on the lower third of the keyboard, and also they're monophonic, low note priority. One thing to note with the envelope for the strings is that all the keys that you play share the same attack, but each key has its own individual release. So if I select a slow attack and release, you'll hear the typical fade in, and then when you release the key, the fade out. So I'll do that again, but I'll press a second key at the same time. So the first key fades in. Since the attack is totally opened up already, as soon as I hit the second key, it'll start immediately. There'll be no attack phase to the envelope. On the other hand, each note has its own release. There's also a separate volume control for the bass, and also a mix between string and synthesizer sounds. The synthesizer is based on four banks of modified square waves, similar to the string section. The upper two banks are labeled synthesizer, and the lower two banks are labeled synthesizer bass. The actual synth is a standard architecture with a voltage control filter and an ADSR envelope. The filter can be modulated by the ADSR envelope, or an LFO, and the controls here at the front, or a pedal hooked into the back of the synth. So it's your typical synthesizer sound. It's fully polyphonic. You'll notice that the triggering, it re-triggers on every single key press, because there's only one envelope, unlike for the string section. So if I push a key and it fades down, now if I press the second key, it'll actually re-trigger any key that's still held down, and so on. So it gives a kind of characteristic sound for this style of polysynth. Also, there's a chorus phaser button, and if you push that, it will pass the synthesizer sounds through the same phaser circuit that the string section has. So this is your typical classic Omni sound. The bass, similar to the bass strings, is limited to the lower third of the keyboard, and it's monophonic, low note priority. One other thing to note is that there's an interaction between the ADSR of the synth and the attack release envelope of the strings. And the string section goes through the signal chain first, and the synthesizer section follows. So the attack release envelope has priority over the ADSR envelope. I'll show a diagram because it's easier to show it graphically. Typically, the Omni is played with a long release on the string sound, so maybe the envelope looks something like that. And of course, at the same time, the ADSR on the synth section has been triggered, and maybe it looks something like that. And as long as the ADSR for the synth is inside the envelope for the strings, Both of the release sections will go right to the end, and the decay on the notes for the strings and the synth will sound normal. On the other hand, if you bring in the string release, so maybe something closer to that, but you don't do anything to the ADSR on the synth, what happens is at this point here where the two envelopes cross, the release on the synth envelope will end early. I'll give a demonstration of that. With the synthesizer section, the release fader is all the way up. So we get a nice gradual decay of the note when you lift the key up. Now, if I take the string release and I put it to minimum, you'll notice that it doesn't matter where this release is on the ADSR, the note decays immediately. That's because the release envelope for the string section is narrower than the envelope, the ADSR envelope for the synthesizer section. If I put the release fader back up, we now get that release sound. Now let's open it up and look at the inside. Here's the Omni with the front panel flipped up. In the back you have the power supply, which is just a regular linear power supply. Also on the back, right below the controls for the synthesizer, is the synthesizer board that has the filter module and the ADSR envelope. At the base of the synthesizer we have two main circuit boards, the upper voice board and the lower voice board, and they create the bank of square waves for all of the keys. And you can see that there's a series of capacitors here, these the blue capacitors. There's one per key, and they give the individual release components of the envelope for each of the keys. The square waves are created using a top octave generator, which is on this board here, and in this scheme a single master oscillator is divided down into each of the frequencies for each key. Let's have a closer look. Here's the master oscillator circuit. There's a slug that goes through this coil, and you can turn it with a screwdriver from the bottom of the synth to change the tuning. Here's the 50240 top octave generator, and the divider chips are underneath these ribbon cables. I'll probe the pins on the top octave generator so you can see the waveforms. That's the high frequency oscillator. The frequency is so high you can't even see the square waves. That's C, B, B flat, A flat, G, and so on, getting lower in frequency as you go down the keyboard. Piggybacking on the lower voicing board is the phaser board. It's a three-stage phaser using an MN3002 Bucket Brigade chip. Let's take a closer look. You can clearly see the three phaser circuits. This is the Bucket Brigade chip, the MN3002. There's an LFO circuit at the top and some op amps down at the bottom. I'll probe each of the LFOs so that you can see the difference in the three phaser circuits. This is the clock on the first BBD modulated by a fast LFO. And this is the clock on the second BBD with a fast modulation, but one that's not as deep as the first clock. And finally, this is the third BBD with the slowest clock modulation, and these three delay stages together give the phaser circuit its distinctive sound. Here's the audio output waveform of one of the string sounds being played alone. You can see the phaser effect. I'll press the phaser chorus button on the front panel to slow it down so you can see it in more detail. Here's the back panel of the Omni. It has a high and low level main output. This is a combined output with both the string and the synthesizer sounds. It also has a dedicated synthesizer only output. The Mark II has a third output, which is the bass voices only. There's also two inputs to control the filter on the synthesizer section. There's a pedal input and also a standard CV input here on the accessory jack. There are two outputs directly from the keyboard, gate out and trig out, and they can be used to control other analog equipment. It's a shame that they also didn't include a pitch CV out from the keyboard, because then this could have been used as a master CV keyboard. There's also a standard sustained foot switch jack. So that's the ARP Omni. Even with its limitations, it still sounds great and it's useful in the studio. Thanks for watching.